All right, lesson 110, visualizing volume units. We're going to be able to explore units of volume and convert between them. We're going to be able to convert like measurement units within a given measurement system. And as always, we're going to continue understanding those concepts of volume. Let's go. So a unit you can use to measure, you can measure length, you can measure area, and you can measure volume. Notice the difference between the three though. So the length could be a centimeter, but if we're using centimeters and we're measuring area, that would turn into a square centimeter. And that would change if we were measuring volume. That would change into a cubic centimeter. We're obviously going to skip this bottom part because we are virtual, but looking up here, we see length. I know that if I'm measuring length, that's just like measuring the side. It's like measuring a straight line. If I'm measuring area, that's for a two-dimensional shape. And we remember talking about last week or in previous lessons that squares are the perfect shape to measure area. They fit into, for a rectangular prism, they fit into those right corners. They have straight edges. They have the same amount of edges. And volume is cubic because we're turning that into a three-dimensional shape because we're measuring length, width, and height. So we're measuring those three things, and that actually turns it into a cube that would fit best in a shape like that. So again, that gives us the three-dimensional measurement. On page 28, I'm going to actually talk through 1 through 3 for you. It has 3 questions here, or 3 parts, and then number 3 has multiple parts to it. Looking at these first parts, though, they asked if a cubic inch was larger or smaller than a cubic centimeter, and how do we know? So if we take a look at this, we can see that a cubic inch is actually larger because an inch is longer than a centimeter. When you're looking at a ruler, you can actually get out your ruler and look at that and see for yourself that an inch is longer. So a cube with 1 inch edges is larger than a cube with 1 centimeter edges. So it also asks you to list some objects. I would like you to do this as well. I'm giving you 2 examples here. A shoebox and a desk drawer would be great objects to measure with cubic inches. So thinking about the size of a cubic inch, it's going to be larger than our cubic centimeter that we've been looking at lately. A shoebox, a desk drawer, those items aren't too big, but they're a little bit larger than maybe, that jewelry box that we looked at last week. Now, moving on to 3, this is where we want to do some math here. So it asks, how many cubic inches do you think are in a cubic foot? This is where I would like you to pause the video and make a prediction. What do you think? How many cubic inches do you think would be in a cubic foot? Again, that's talking about volume. Now, B and C is going to help us start thinking through that. It says, how many inches are in a foot? Well, we know that there are 12 inches in 1 foot. So I'm going to write the number 12 there. You should too. Again, remember, we're in your math journal on page 28 and 29. Now it asks us, how many square inches are in a square foot? Well, I'm going to come over here to talk about that. I know that square means area. Area equals square feet. Area is length times width, and area is two-dimensional shapes. You can see that we have the answer of 144. And how do we know that? Well, since 12 inches equals 1 foot, and you can see that in my thinking up here of some little notes that I took, and I suggest you doing the same thing when you have questions like this. Write notes off to the side that help you think through this. That way you can refer back to them. That way if your answer goes wrong somewhere, you can look back at your notes and try to figure out where exactly you need to fix your errors. Anyway, back to this. Since 12 inches is 1 foot, a square foot would be 12 inches long and 12 inches high, giving us a 12 by 12 because up here we saw length times width. So 12 times 12 is 144, giving us 144 square inches. And here we have a square for you just to give you a visual for that. If this is a 1 foot length side and this is a square, so this would be 1 foot. This is a 1 square foot. This is 1 square foot. Okay. Now I know right here, 12 inches equals 1 foot. So I'm going to label this side in inches. It's okay. They're the same thing. 12 inches is the same as 1 foot. And I'm going to label this 12 inches. Okay. So what you see here is you have a 1 by 1 foot, so square foot, or you have a 12 by 12 inch, giving us that 12 times 12 equals 144 because area equals length times width. Now, moving on to number 3, part D, it's asking us how many cubic inches are in a cubic foot. This is taking our two-dimensional, like I mentioned over here, square is two-dimensional. We're taking two-dimensional and moving it to three-dimensional. So I want you to think about, we're taking that two-dimensional area of length times width and we're creating it into a three-dimensional shape. And so you're going to need to figure out the volume. Okay? So you want to use information from this slide right here that we just looked at, or those problems. So 1 and 2, where you're thinking, and then 3, the information that we just talked about with the 144 square inches. I want you to think about the two formulas for volume that we have talked about the last couple lessons. Pause and try to come up with what are those two formulas that we talked about in lesson 1.9. All right, hopefully you came up with the two formulas that I've got right here. I've got volume equals length times width times height. And if you haven't seen this before, the little dots in between a number or the letters, that represents multiplication. So there's multiple ways to represent multiplication when you're writing it down, and a dot in between represents the multiplication sign as well. Below that, you see the second formula. Volume equals capital B times H. If you can look at the two, you'll remember that this B right here, this capital B, represents the length times the width, or the area. Well, we already found the area in part C. So take that information, pause your video here, and I want you to complete D and number 4. So tell me how many cubic inches are in a cubic foot, and explain your answer in your journal. Then take a moment and think about how big that object is. What kind of objects would you measure in cubic feet? Comparing that to when we did, a shoebox and a desk drawer for cubic inches. Think about what would you measure in cubic feet. Again, pause your video here and then come back and check with me. All right. Hopefully you got 1,728 cubic inches are in a cubic foot. How do we know that? Well, take a look here. Hopefully you wrote something similar to this. There are 144 square inches in 1 square foot. We learned that from C. So it takes 144 cubic inches to cover a square foot. A cubic foot is also 12 inches high. So there would be 12 layers. Therefore, we're going to take 144 times 12 and get 1,728. The formula that works out best for that is this one right here. Volume equals the area of the base times the height. But you could also take 12 times 12 times 12. it would still give you the same 1,728. Moving over to number 4, the objects. Well, we know the objects should be larger than the ones that we listed in cubic inches. So maybe like a closet, a locker, the trunk of a car. Those are all objects that would work out really well with cubic feet. Now this is moving even further. We've talked about how many cubic inches are in a cubic foot. Now we're going to talk about how many cubic feet are in a cubic yard. For this, you need to know how many feet are in 1 yard. This is kind of a challenge question. I want you to pause here, use the information that we've been using, use your knowledge about conversions of feet to yards, use that SRB on the Everyday Math site if you have access, and then think about what kind of objects would you measure in cubic yards. Again, pause the video here, try this out. Hopefully you found that there are 27 cubic feet in 1 cubic yard. How do we know that? Well, we know that there are approximately 3 feet in 1 yard. That means that there are 3 by 3 or 9 square feet in a square yard. And then you're going to take that 9 times 3 or 27 cubic feet in a cubic yard. Using that same thing, you could do volume equals 3 times 3 times 3, or you could do volume equals 9 times 3. So moving even larger than our last one, we know the object should be larger than those listed for the cubic feet, but this time maybe something measured in cubic yards would be a warehouse, a hallway, a cargo ship. I'd be interested to know what things did you think of measuring in cubic yards? So using the information we've been practicing with, we're looking at number 7. It says Dina's family has a freezer that is 2 yards in width, 1 yard in length, and 1 yard in height. What's the volume of the freezer? And we want to find the volume of the freezer 2 different ways. They're asking us, what's the volume in cubic yards? And then also taking that and telling us, what's the volume in cubic feet? Okay? And also thinking, do you think cubic yards or cubic feet are better units to measure the volume of this freezer? Why? So let's pause and do 7A, okay? Just do 7A, pause your video, and then come back. All right, so if you did it like me, I just did volume equals 2 times 1 times 1 right here, and I got that it was 2 yards cubed, or 2 cubic yards. So taking that 2 cubic yards and the information that we have talked about on the previous problems on pages 28 and 29, take that information and figure out how many cubic feet fit in the freezer. Pause the video now. If you do it the correct way by taking 6 times 3 times 3, you will find that it is 54 cubic feet. Well, how did we get 6, 3, and 3? Remember that 1 yard equals 3 feet. So if we have 2 yards, that's going to equal 6 feet. You just do the conversion. So instead of a 2 times 1 times 1, you'd have that 6 times 3 times 3. And then you would get your answer of 54 cubic feet. Moving on to page 30 in your journal, we're going to do some more practicing with those cubes in the rectangular prisms. We are using cubic units again for 1 and 2. I'm just going to show you these problems, and then this is your independent work that I want you to do and try. So again, thinking about the different formulas for volume. Volume equals length times width times height. Volume equals the area of the base times height. One thing I want you to remember as well is think about these cubes. The base can be any of these sides. So just because this right here isn't filled in, maybe this is filled in more and you can figure out what that area of that base is. Because a rectangular prism can be sat on any of its sides. Think of a box. So this one is cubic units. Number 2 is cubic units. And then number 3 is cubic units as well. 4 is a try this, and I really want you to try it. It says, the stack of cubes represents the height of a rectangular prism. Draw the outline of a rectangular base on the grid paper so that the volume of the prism would be 60 cubic units. Okay? So this is one that's really going to have to make you think about that formula. You need to figure out, you see the height already. Now you need to think, okay, I've got the height. What would that need to be multiplied by to get 60 cubic units? Then, before we stop, I'm going to talk to you about your math boxes for 110. We can see that 1 is talking about volume. Okay, so can A has a volume of 25. Can B has twice as many. What is the volume of can B? It's how many beans can it hold. 2 says find the area of the rectangle that is 1.5 feet by 2 feet. Remember, we practiced some of that with, using the halves. That was early on in our unit. I'm sorry, that was find the area. I think I said volume, but it's find the area. 3 and 4, number 3 is if 329 plus 671 equals 1,000, what is 2 times 329 plus 671? Number 4 is doing some conversions, yards to feet, miles to feet, inches to yards, feet to inches. And 5 and 6, number 5 is practicing those parentheses, the grouping symbols. And number 6, Maria bought 5 tickets for $20 each. Each ticket had a $2 fee. Write an expression that shows how much Maria paid for the tickets. So she bought 5 tickets for $20 each, and each ticket had a $2 fee. How much did she pay in all? So now that I've shown you your math boxes and page 30, pause your video now. Work on those. Work on page 30. Work on your math boxes. When you're completed with everything, come back and check all your work. All right, let's take a look at 1 and 2 on page 30. You should have gotten a volume of 160 cubic units. 1, 2, 3, 4, 5 is the height. 8 is the length. And 1, 2, 3, 4 is the width. Number 2, same type of method. Volume would be 100 cubic units. Number 3, if you did length times width times height, 384 cubic units. Don't forget that even if you can't see a box back there, it's still there. It's just hidden from the boxes on top of it, in front of it. And if you did number 4 the correct way, you should have drawn an area similar to this one with 12 unit squares. You could have done a 3 by 4. You could have also done a 6 by 2, 3 by 4, or 6 by 2. Now, math boxes. Number 1, 50 beans. Number 2, 3 square feet. 3, 2,000. Number 4, 100 yards equals 300 feet. B, 2 miles equals 10,560 feet. C, 72 inches equals 2 yards. And D, 2.5 feet equals 30 inches. And 5 and 6. For 5A, we've got 2, 12, and 30. And then an example would be 20 plus 2, or 2 plus 20, times 5. So the reason is that each ticket cost $20. Then each ticket had a $2 fee. So really they were $22, and she bought 5 of them. So hopefully you got 22 times 5. Now that you have completed all of our work for today's lesson, You've completed your math boxes portion of your independent work. Check out the lesson 1.10 independent work, and don't forget to submit your assignments when you're completed.